if we were to take a piece that is a fourth and compare it to a size that's an eighth, those are not the same size pieces at all. So you cannot compare them right away. You have to think of how many pieces of the small could fit onto the larger one. How many eighths could we get onto the fourth? Well, that doesn't kind of cover it up quite yet. Let me try another. Well, that covers the fourth completely. It fits perfectly over the top. So 2 of the eighths, 2 of the pink, is the same as 1 of the fourths. Let's see if I can take a fourth down and fill it in. Yes, it works. So we call these equivalent fractions. 2/8 is the same as saying 1/4. It's a different name, but it's the size of the pieces. 2 of these is the same as 1/4. Let's see if our half works. If I were to cover up the fourths, I would be able to cover 2 of the fourths being equal to 1 of the halves. Do you see it? If I turn it around, I could do the other side. 2/4 is the same as 1/2. What if I cover up the sixths? That fits over perfectly. 1, 2, 3 of the sixths is the same as 1/2. And the eighths, I could cover up 4 of the eighths. 1, 2, 3, 4. I could cover those completely with the blue. If I turn it around. Look what happens when I cover up the thirds, though. There's part of this third that's sticking out. You see that piece? If I were to put it over the top of the blue, you'd see it better. Here's 1/3, and here's another. But it's hanging over, and you'll see better too. If I cover up 1 of the thirds completely, and then this much of the third is sticking out. So 1/2, when I put it over the third circle, has some extra. These were perfect. 2/4, 3/6, 4/8. Sometimes they work out perfectly, and sometimes they don't. If I was to take a third and try to put it over the fourth, look what would happen. It would cover up 1 of the fourths and part of another. But on the sixths, I'm going to cover 2 completely. 1, 2. Those are equivalent fractions. 2/6 is the same as saying 1/3.